Right now, while you are watching this, something is happening that almost nobody on Earth knows about. Somewhere between us and the sun, an object is falling. It has been falling for a very long time. It is made of ice and dust and rock, and it is heading straight for the one place in the solar system where nothing made of ice can survive. It is not a planet. It is not an asteroid on some wide, safe orbit. It is not a spacecraft we sent. It was here before the first telescope. It was here before the first city, before writing, before anyone thought to look up and keep a record. It has been on this path for centuries, and it is small, not moon-sized, not mountain-sized, most likely about 10 meters across, smaller than a house, a single dark boulder of frozen material, falling toward a star a million times wider than the Earth. In a matter of hours, it will be gone, vaporized, erased so completely that there will be nothing left to find. Here is what makes this strange. This is not rare. Scientists used to believe objects like this were almost never seen. Then one spacecraft started watching the sun without blinking, and the number it found was not 2, or 20, or 200. It was 5,000. The people running that count have described reaching that number as almost impossible to believe. This is the story of a sun-grazing comet, one of 5,000. And here is the part the headlines are not telling you. It is not just that we found it. It is what these falling comets are teaching us about the sun. The same sun whose storms can reach across 93 million miles and knock out power grids here on Earth. It is what is happening right now to the one machine that has watched them for 30 years. And it is what will keep happening long after that machine goes silent, because there is nothing, anywhere, that can stop it. Stay with me, because by the time this is over, you will never look at a picture of the sun the same way again. To understand the comet falling today, you have to go back to a man working with a pencil. His name was Heinrich Kreutz. He was a German astronomer, born in 1854. By the time he did the work that would carry his name, he was in his early 30s, sitting at an observatory in the city of Kiel. His job was one of the most tedious in all of science. He took the raw positions of comets, dates, angles, faint marks recorded by other observers, and he calculated their orbits by hand. No computer, no calculator, just paper, patience, and the mathematics of gravity. Most people would have seen a pile of unrelated comets. Kreutz saw something else. He was studying a handful of enormous comets that had appeared over the previous decades. The Great Comet of 1843, the Great Comet of 1880, the Great Comet of 1882. Each one had blazed across the sky. Each one had passed shockingly close to the sun. And each one, most people assumed, was its own separate visitor, arriving by chance. Kreutz did the arithmetic, and the numbers refused to be a coincidence. These giant comets were not traveling on random paths. They were traveling on nearly the same path, the same steep dive toward the sun, the same angle, the same route through space. In 1888, he published the conclusion in the leading astronomy journal of his day. These were not separate comets at all. They were pieces, fragments of one original, colossal comet that had broken apart, long ago, and scattered its children along a single orbit. That was the turning point. For the first time, someone had proposed that a whole family of comets could descend from one shattered parent. The family was later named after him, the Kreutz Sungrazers. And then, for a while, almost nothing happened. After 1888, no new comets on that orbit turned up for decades. Kreutz died in 1907, still the editor of that journal, his idea quietly waiting. For most of the next century, only about 30 of these sun-grazing comets were known in all of recorded human history. 30. That was the entire catalog. Nobody knew that just above the sun, hidden in the glare, there were thousands more falling in, one after another, unseen. We simply had no way to look. To see them, we would have to leave the Earth entirely and build a machine to stare at the sun. So what exactly is falling into the sun, and why can't it survive? Start with what a comet is. It is a leftover, a dirty snowball of ice, dust, and rock, frozen since the birth of the solar system. Out in the cold, it does nothing. It just drifts. A sun grazer is a comet on a very particular orbit, not a gentle loop. A long stretched dive that carries it in toward the sun and then whips it around at the bottom, closer to the surface than almost anything else that moves. Watch what happens on the way in. Sunlight heats the frozen surface. The ice does not melt into water. It sublimates. It turns straight from solid into gas. That escaping gas drags dust with it, and the dust catches sunlight. That is the tail. That glowing streak is not fire. It is a boulder losing itself, molecule by molecule. Now bring it closer. A Kreutz comet's path takes it to within about 2 sun-widths of the surface, close enough to graze the outer atmosphere of the star itself. At that range, 2 things tear it apart at once. The first is heat. This close, the sun strips material away faster than a small nucleus can hold together. The second is gravity, not as a pull, but as a stretch. The sun's gravity yanks harder on the near side of the comet than the far side. For a body this small and this fragile, that difference is enough to pull it apart. It crosses a line called the Roche limit, the distance inside which a loose pile of ice and rubble simply cannot stay whole. And it is moving fast. At its closest approach, a sungrazer can reach roughly 500 kilometers per second. 500 kilometers every single second. Fast enough to cross the entire United States in about the time it takes to say the word. You might expect something moving that fast to punch through and come out the other side. It does not. It disappears. A 10-meter boulder, heated, stretched, and stripped, does not escape. It fades. It fragments. It vanishes, usually before it even reaches the bottom of the dive. Here is the problem that kept us blind for so long. You cannot see these comets from the ground, not with the biggest telescope on Earth. The reason is simple and unforgiving. They die right next to the sun. In our sky, they are only a few degrees away from it. To look at a sungrazer from your backyard, you would have to stare into the full blazing face of the sun and pick out a faint smudge sitting beside it. The glare erases everything. So for 30 of these comets across all of history, we were mostly lucky. They were the giants, the great comets of the 1800s, bright enough, for a few days, to be glimpsed low on the horizon at dawn or dusk. The small ones, the 10-meter boulders, we never had a chance. To catch those, you need to do one specific thing. You need to block out the sun. The instrument that does it is called a coronagraph. Inside, it sits a small disk that covers the bright face of the sun exactly, creating an artificial eclipse on demand. With the glare hidden, the faint region around the sun becomes visible, the corona, the outer atmosphere, and drifting through that region, tiny and ghostly, the comets appear. But you cannot do this from the ground either, because our own atmosphere scatters sunlight everywhere. You have to go to space. So we did. There is a spacecraft parked about 1.5 million kilometers from Earth, on the line between our planet and the sun. From there, it has an uninterrupted view. It never has to wait for night. It never has cloud. It stares at the sun, hour after hour, year after year. Its coronagraph blocks the star and watches the region just around it, the exact zone where sungrazers make their final approach, and the comets it hunts are almost nothing. 10 meters across, faint, visible for only a few hours, rarely more than a day or two, before they are destroyed. There is no second chance to observe one. There is no way to send anything to intercept it. By the time you have confirmed a comet is there, it is already dying on camera. That machine, 1.5 million kilometers away, blocking out a star to catch a falling boulder, that is how we finally learned the truth. And the truth was not 30 comets. The spacecraft is called SOHO, the Solar and Heliospheric Observatory. It is a joint mission of the European Space Agency and NASA, and it launched on December 2, 1995. It was designed to study the sun itself, its surface, its interior, its atmosphere. Hunting comets was never the plan. It found them anyway. Before SOHO, remember, humanity knew of about 30 sun-grazing comets, total. SOHO passed 100, then 1,000. Then, in March of 2024, it crossed its 5,000th comet. 5,000, it is now, by a wide margin, the single most prolific comet discoverer in the history of the world, more than every observatory and every astronomer who ever lived combined. Sit with that number, because it breaks the old picture completely. These comets were never rare. We were simply never watching. There is, in effect, a near-continuous stream of small comets falling into the sun, a new one turning up every few days, on average, for decades. Imagine believing an event happens perhaps once a generation, and then discovering it has been happening, quietly, every few days, the entire time. That is the size of the correction. 5,000 comets, and what remains unexplained is not whether they are there, It is how many more the original parent still has left to give. Here is the second thing Soho confirmed, and it reaches straight back to that man with the pencil. Of those 5,000 comets, the overwhelming majority, roughly 85%, belong to a single family. More than 4,000 of them are Kreutz sun-grazers. All of them ride nearly the same orbit. All of them dive toward the sun from the same direction, at the same angle, just as Heinrich Kreutz predicted from only 3 comets in 1888. Think about what that means. More than 4,000 separate objects, each falling into the sun, and they are not strangers. They are relatives. They are the shattered remains of one enormous comet that broke apart long ago and has been quietly dropping its pieces ever since. It is like finding 4,000 shards scattered across a floor and realizing, from the way each one is shaped, that they all came from a single vase that shattered centuries before you were born. And here is what researchers still cannot fully pin down: the parent. We do not know for certain which comet it was, or how big. Some models trace the family back to a giant comet recorded in 371 BC. Others point to an enormous comet seen in the year 1106. The largest surviving fragments seem to circle back on a rhythm of roughly 700 to 800 years. But the original, the one that started it all, is gone. We are left reading its will, one falling piece at a time. Now, the strangest contradiction of all. These comets are tiny, 10 meters, a boulder, and yet, for a brief window, some of them shine. As a sungrazer falls inward, it does not simply fade into the dark. It brightens. It keeps brightening as it approaches, glowing more and more intensely, until it reaches a point about 12 sun-widths out. And then, quite suddenly, it begins to fade and die. Why? Because that inner region is where the dust it has been shedding starts to vaporize outright. The very thing that made it glow, dust catching sunlight, is being destroyed. The comet burns brightest just before it is snuffed out. Sit with the scale of that. A chunk of ice the size of a house, roughly 150 million kilometers from Earth, made visible to us only because we launched a machine 1.5 million kilometers into space to block out a star 1,000,000 times its size. We are watching a boulder die next to the sun, and we can see it. That should not be possible. It is. And even here, there is a mystery. Some of these comets do not brighten smoothly. A few flatten out, or flicker, or briefly flare again. Signs, researchers think, that the nucleus is breaking into pieces in real time. What exactly governs that final unraveling, we still cannot fully explain. So the comet is falling. It is brightening. And then, almost always, it does the thing that still feels wrong every time you watch it. It dies. On camera. In front of us. The vast majority of Kreutz sun-grazers do not survive their close approach. They fade, they fragment, and they vanish near the bottom of the dive. Consider one that Soho caught in July of 2011. It was discovered on the 4th. 2 days later, on the 6th, it was gone, destroyed at its closest approach to the sun. From discovery to death, 2 days. That timeline is normal for these objects, not the exception. Now hold that against the speed. 500 kilometers per second. Your instinct says something moving that fast should tear straight through and survive on the far side. Instead, it evaporates. Speed does not save it. Nothing saves it. The sun does not need to hit it. It only needs to be near. There is, very rarely, an exception. In late 2011, a larger Kreutz comet, Comet Lovejoy, plunged in, disappeared behind the sun, and then, astonishingly, came back out the other side, battered but intact. It was the rare survivor, and it stood out precisely because almost none of them do. What still remains unsettled is the exact cause of death. How much is the heat? How much is the tidal stretching? How much is the sublimation? And why a rare few, like Lovejoy, make it through when thousands of their siblings do not? Here is the turn most people never hear. These deaths are not just spectacle, they are science. Every falling comet is a free probe of the sun. Think about it. We can rarely send a spacecraft skimming through the sun's outer atmosphere, but nature drops probes in for us, every few days. Small, doomed, but perfectly placed. As a comet plunges through the corona and the solar wind, the way it lights up, the way its material behaves, tells researchers about the environment it is passing through, about the sun's atmosphere, about the wind of particles streaming off our star. That 5,000 comet dataset is unlike anything else in astronomy. Thousands of objects, all diving through the same region, recorded for decades. It is a genuinely unique record, and that is the part that touches you. The sun is not a quiet neighbor. Its storms hurl charged particles across 93 million miles of space. When a big one arrives, it can disrupt satellites, scramble navigation, and, in the worst cases, damage power grids on the ground. Understanding the sun's atmosphere is not abstract. It is the difference between seeing that weather coming and being caught by it. There is one more human detail here, and it is worth saying plainly. Most of those 5,000 comets were not found by professional astronomers. They were found by volunteers, ordinary people around the world scanning the spacecraft's images from home, through a NASA citizen science effort. The most prolific comet hunter in history is a spacecraft. The eyes that actually spot the comets belong to the public. So where does this go next? SOHO launched in 1995 for a mission that was originally meant to last 2 years. It has now watched the sun for 30. It has survived crises that nearly ended it. But it is old, far beyond its design life, and its mission is being wound down. Its end has already been placed on the calendar. When that day comes, the longest continuous watch ever kept on the sun's near space will pause. Other instruments exist. Newer coronagraphs on other spacecraft help fill the gap. But nothing else has SOHO's 30-year baseline, its unbroken record, its 5,000 comets. When it goes quiet, a specific window closes, and it does not reopen easily. But here is the line that matters most. The comets do not stop. The stream of sun grazers is not something SOHO created. SOHO only revealed it. The shattered parent is still out there, still shedding fragments, still feeding pieces into that same long dive toward the sun. New comets will keep falling in, one every few days, 10 meters across, 500 kilometers per second, whether or not a single instrument is pointed at them. There is nothing to stop it. There is nothing that could. And some researchers expect the family is not finished with its dramatic moments. The largest fragments are still out there, on their long, slow orbits. In the coming decades, we may yet see another truly great Kreutz comet. A bright one, a survivor. The kind that lit up the sky in 1843 and 1882. Whether we will be watching with the same care, or whether the eyes will have gone dark by then, is the open question. The falling never ends, only our attention does. So this is where we are. 5,000 comets, most of them no bigger than a house. A single family of more than 4,000, all pieces of one comet that broke apart before recorded history. Boulders 10 meters across, falling at 500 kilometers per second into a star that erases them in hours. And one machine, 1.5 million kilometers from Earth, that has spent 30 years blocking out the sun so we could watch it happen. The comet falling today will be gone by tomorrow. Another will take its place within the week. That has been true the whole time. We only just learned to see it. When that spacecraft finally goes quiet, the falling will continue exactly as before. But the record will pause. And for a while, maybe a generation, the count will simply stop climbing. If this is the kind of thing you want to keep seeing, real discoveries, explained honestly, grounded in published research rather than exaggerated headlines, subscribe, and turn on notifications so the next one reaches you. There is a great deal still falling into the sun. It is worth having something pointed at it.